All right, so let's finish the rest of this practice exam here. All right, so we have this figure 2 here we're going to use to answer 2 questions. Yeah, 16 and 17. So we'll draw these out. Marginal revenue, marginal cost, demand, average total cost. That's A. Here's B. All right. Here's C. Right here. And D here. Demand straight across, average total cost. Marginal cost there. All right. All right. So what else? Which of these graphs could depict a short equilibrium that encourages the exit as a firm from monopolistically competitive industry? Well, A, B, and C would all be monopolistic competition. Downward sloping demand curve, they have some market power. Whereas D here is perfectly competitive. So we can automatically get rid of D here. And we want to know, okay, what would encourage the exit of some firms? This is when price is less than average total cost, where they're maximizing profits. So let's go through these. All right, they're producing here. This is where they're going to produce at, right here. Marginal cost equals marginal revenue. They have this markup. Well, price and average total cost are the same here. So this is a stable long-run equilibrium. Firms are going to enter or exit here. What about B? Well, here's your quantity. Here's your price. It's actually below the average total cost. So that's going to be B. It's actually below the average total cost. Some firms are going to exit because of that. In the long run, when they can do something about it, they're going to exit. And so, that's B, panel B. 17. Which of these graphs depicts a short equilibrium that will not encourage either the entry or exit of firms in a monopolistically competitive industry? All right. Well, that's going to be this one here. The average total cost, it's neither, below or above. So since it's, if it was above it, that would encourage firms to enter. If it was below it, firms would exit. But nothing's going to change here. This will actually be a stable long-run equilibrium in this case. But, firms are going to enter or exit here. So that's going to be panel A. All right. Let's erase this. Okay. All right. Some firms have an incentive to advertise because they sell. All right. If it's a homogeneous product, like in perfect competition, well, then, there's no need to advertise. Okay. So you can eliminate A and B. C and D, a differentiated product, which is what you would advertise. Hey, my product's different. This is why it's better. And also the price would actually need to be above the marginal cost, because if it was equal to the marginal cost and you start advertising, well, then your price is going to be lower than your marginal cost, and you're definitely going to be losing money on that. It wouldn't make any sense to do that in this case. Right. So it needs to be D. You need to have the price above the marginal cost. Otherwise, if you start advertising, you're definitely going to be making a negative profit. And you're not going to stay in that business. Okay. So that's why it's going to be D. 19. The fundamental source of monopoly power is barriers to entry. Right? That's why you have monopoly power. For whatever reason, you don't have to worry about any competitors. And because of that, like you are the market. And as you increase and decrease your production, you get to enjoy this monopoly power. Okay. But if there's no barriers to entry, other firms can enter and they can compete with you. And because of that, it's going to move you away from this. They're still going to have some market power, but not as much. And you're not going to get as much profit, though, as a result of this. 20. Which of the following represents the firm's long-run condition for exiting a market? Remember, exit if the price is less than average total cost. That's what you're concerned about. Okay, what's my average total cost per unit? How much per unit does it cost? Well, what do I get per unit? If it's less than that, well, you got a negative profit. You're going to exit. So that's going to be C there. All right. Make sure you remember these long run, short run conditions. There's going to be questions asking that. Make sure you get this, understand this point, this distinction between the long run and the short run. 21, let me erase this. We're going to be using this diagram here, so I'll draw it out. Price, quantity, curve A, which is their demand curve. Make sure you know what these are. Curve B, that's marginal revenue. It drops twice as fast, twice as steep as demand curve. Marginal cost here, that's curve C. Curve D looks something like this. And that's average total cost. And let's put some prices here. Price 0, price 1, price 2, price 3, and price 4. All right, what about quantities? 0, there, 1, that's 2, that's 3, and that's 4. So we have two questions here, 21 and 22. 21 asks, if the monopoly firm wants to maximize its profit, it should operate at a level of output equal to, well, it's going to maximize profits when marginal revenue equals marginal cost. So there's your marginal revenue, marginal cost. Here's your marginal revenue. So it's going to produce right here. And so the quantity would be 2. That's going to be B. Q2, the quantity. 22 asks, profit will be maximized by charging a price equal to what? Well, you're producing here at 2. You don't charge this price, you actually can mark it up. This is what consumers are willing to pay here on this demand curve. So you actually charge price 4. So that's going to be D. Okay. Make sure you understand this diagram, how this works. Okay. And this could be a monopolistic competition or monopoly. Either way, you're showing, you're showing right here where you have like a markup. And you produce where marginal cost equals marginal revenue, and the price is not constant. All right, your production impacts, because here, your market, or if you're monopolistic competition, you have a little bit of a market power because your product's different. Okay. Um, 23. A monopolistically competitive industry is characterized by many firms. There's no barriers to entry. And so free entry is going to be a part of that. That's why there's many firms, because it's free entry. And distinctive from perfect competition, perfect competitive market, there's differentiated products. And so that's going to be B. Okay. All right. So 24 and 25, we're going to use this little game here between Toyota and Honda. They're competing. They're competing by offering 1% financing for new cars. Now they'll lose a little money on this financing, but it helps them to get business. So in actuality, they'd both be better off if they didn't do it. They might not sell as many, but they get more interest on financing cars at a higher rate. But because if one or the other one does this, then they'll lose a lot of business to them. So they have to do this to kind of compete with each other. And as a result, they end up making a little bit less profit than they would. So this is what this game is going to illustrate here. So we got Toyota, who's the role player. They can either don't offer or offer. This is the payout matrix. We have Honda as the column player. They can either don't offer or offer. And here's the payouts. If both of them don't offer this 1% financing, Toyota gets $250, Honda $240. All right. The row player here, their payout is always on the left. The payout for the column player here is always on the right. Okay. So if Toyota doesn't offer and Honda offers, Toyota gets 40, Honda 350. Okay. You see what happens? If Toyota doesn't offer this 1% finance and Honda does, well, a lot of people will buy Hondas now, so their profit will increase. Okay. Whereas Toyota will lose out, and so they'll get less profits. Now, if Toyota offers and Honda doesn't offer, well, then Toyota will get 360, Honda 50. And if both of them offer 140, 130. All right, so what's the dominant strategy for Toyota? Or if there is one. All right. Well, let's look at the point of view of Toyota. They're always going to make their move based off what they think the other person does. So if Honda doesn't offer, they have a choice between 250 and 360 if they offer. Well, they're better off offering here. Okay, 360 is more than 250. What if Honda offers? What's their best move? Well, they have a choice between 40, 140, and 140 here. Well, they're going to choose the 140. Okay. So they're always going to choose to offer here. That's their dominant strategy. Okay. And so that's going to be 24 will be B. What about 25? It's asking for the Nash equilibrium. So we need to look to see what Honda does as well. We know what two moves Toyota. They're always going to choose offer. Well, let's look at Honda and see what they do. Honda here is looking at Toyota. If Toyota doesn't offer, well, they're looking at a payout of 240 and 350. Well, they're going to choose to offer to get this 350 if Toyota doesn't offer. What about if Toyota does offer? Well, they're looking here at a payout between 50 if they don't offer and 130 if they do. Well, they're going to choose this to offer here. So they have a dominant strategy of always choosing offer as well. And it's how you know which one's a Nash equilibrium. What's the one that has both of them underlined, or you can check by them too. Both of these are checked. So the Nash equilibrium, Toyota offer, and Honda offer. Okay, so that's going to be C. Now, why is this, they're better off right here, right? 250 and 240. Why isn't that the Nash equilibrium? Well, it's because here there's an incentive to cheat and deviate. Remember, Toyota and Honda, they're concerned about their own profits. They can answer their own people that are their stockholders. They're concerned about them. So if Honda's like, well, okay, I won't offer. Okay. Well, Toyota has incentive to cheat or deviate because they can get 360, which is more than 250. Well, what happens to Honda here? Well, they lose out. They're losing profit. So it hurts them. Okay. And it goes the same for Honda. They could deviate and be better off. If Honda deviates and Toyota's like, okay, I'm not going to offer. Well, Honda could be like, well, instead of 240, I can get this 350. But what happens to Toyota? Well, they lose out. Right? And because they're never going to come to any kind of agreement where they cooperate here, because they know the other person could deviate from this and it could harm them because it's going to help them. And that's why this is a stable equilibrium here, this Nash equilibrium. And where they both offer, there's no incentive for either one of them to cheat at this point, right? Because if they deviate from that, well, they'll end up losing money, okay? So this is why this is a stable Nash equilibrium here, when you got two people competing that are self-interest, all right? So that's it for that. So let's go to 26. Which of the following leads to a better societal outcome when firms collude here? Okay, so what's better for society here? Two firms fishing from the same lake, two firms producing tires, two firms drilling for oil. So basically what we're saying is like, okay, if they collude here, they're going to produce less. You know, it increases their profits, but it's actually better for society. Well, this happens when you have a common resource, or it could be like some kind of agreement between governments to prevent like a nuclear war or something. But when you have a common resource, it's actually better when they collude because less of this resource is used up when that happens. So it's going to be when two firms are fishing from the lake and two firms drilling for oil. So that's going to be D. It's both A and C. Why isn't B? Two firms producing tires. Well, it's bad when they collude because they produce less tires, and as a result, they're getting a higher profit, and there's less, there's less surplus as a result of this. And this isn't a common resource. Tires are synthetic now. It's not like a resource that people are sharing. So you're better off getting this, higher surplus, more efficient outcome. And that's why B is not the case. It's not the case where it's better for society. 27. A somewhat controversial business practice is when a firm offers offers two goods together. Okay, what is tying? That's when okay, you're trying to get advantage here. I'm offering this other product with this because I've already got I got some market power with this one good. If I offer this other one, that gives me kind of advantage here. I can offer it maybe cheaper, and I can get customers easily that way, right? And so that's what is tying. Okay. These other ones, resale maintenance. That is like what price do you have to sell at? It's saying, okay, somebody's selling this good for you, reselling it. So you tell them, okay, you got to charge this price. Predatory pricing, that is like when people are charging a price, trying to undercut each other, put the other one out of business. The last one is cartelization. That's when firms collude together. That's what that is. But the one where you offer the two goods together, it's called tying. And it's kind of controversial. Is that bad or not? I mean, there's arguments for and against. Like both of them, there's good points on both sides. It's kind of a difficult one to see whether that's an issue or not. It kind of depends on the situation, honestly. Well, so let's do these last two problems. Problem 28. Did I not finish that? I thought I wrote that down. Yes, I did. But anyway, okay, let's do 28 here first. So Marty owns a mango farm, and the market price is $4.50 per pound. His marginal cost can be shown by 1/3 Q. And his profit maximizing quantity, when he's producing it, the average total cost is $5, and the average variable cost is $4. So first, we want to find the profit maximizing quantity and solve for total profit. So we want to set marginal revenue equals marginal cost, because we know that's when firms maximizing profits. And we're in a perfectly competitive market here, so we know price will be equal to marginal revenue. So we just set price equals the marginal cost. Our price is $4.50. Marginal cost is 1/3 Q. Multiply both sides by 3. And our quantity here is going to be 1350. This is the quantity that maximizes profits here. Okay. Now we want to solve for the total profit. That's total revenue minus total cost. Or you can rewrite that as price minus average total cost. That gives us the per unit, and then just multiply it by quantity. That'll give us this total profit here. So the price that we have is $4.50. Average total cost is $4. I'm sorry, $5. Yeah, $5. That's that. I was looking at average variable. Average total cost is $5. The quantity we said they're going to produce, that's $13.50. So what is this going to be? Well, essentially they're losing 50 cents for each unit they produce. And they're producing 13.5 units. So the total profit is going to be negative $6.75. Okay, that's your total profit. All right, so let's answer some questions. So you stay open in the short run. Well, as long as the price is higher than the average variable cost, you stay open. Price is $4.50. Average variable cost is $4. So stay open in the short run. All right. So you stay open in the short run. What about long run? Remember the long run, you look at the price, and as long as the price is greater than the average total cost, you stay open. All right, what's the price? $4.50. And what's the average total cost? It's $5. Well, it's less. So you're going to close down. Close down and exit. You exit the market along with other firms. Some other mango farmers may exit as well if they have similar marginal costs and average total cost is Marty here. Okay, so you're going to exit in the long run in this case. All right. I don't know why I thought I had this written down. Weird. Okay, so I'll just have to work through this as I go. Hopefully I'll get the math. Do the math fairly easily. Well, I haven't used a calculator too much. All right, 29. So here we got the Alamo Draft House Cinema. Is our house cinema located in Austin, Texas? So they can buy the rights to show films for $3,000 a week. We're going to assume this is the only cost, which that isn't not the case, but to simplify things, $3,000 a week. These are their total costs. All right. We're saying the marginal cost is 0 here, just to kind of simplify things. The manager needs to know what price to charge to maximize her profits. There are 200 cinephiles that will pay $20 a ticket. But there's 500 casual film goers that will pay $12 a ticket. If there's no price discrimination, which price should she charge? All right, and then what will the total profit be? So let's look at $20 a ticket. Well, profit equals total revenue minus total cost. Total revenue will be the 200 cinephiles that will pay $20 a ticket. Total cost here is $3,000. So what is that? That's $4,000 minus $3,000. So the total profit in that case is going to be $1,000. Okay. Well, now we need to look at, okay, what if it's $12 a ticket? What's the profit? Well, now there's 500 people that will go see the movie. So the revenue will be 500. Now the prices are getting less, but there's more people that'll go see it. Total cost is the same. It doesn't matter that more people are showing up. And we're kind of, like I said, simplifying this problem. It's not maybe necessarily realistic. But that's 6,000 minus 3,000. The profit there in that case would be $3,000. So you're going to choose this one. This gives a higher profit of $3,000 versus 1,000. Okay. So without price discrimination, you're going to charge $12 a ticket to everyone. Well, what about there is price discrimination? The second part. And somehow you could like have it set up where you could charge maybe certain times or certain you get a sneak peek at a movie first for everyone else. You charge them $20 for it. That way this gets these, cinephiles out quicker than the casual film goers. But because the price is a little bit higher, but they're willing to pay that. There's some way you could get some of this, you could discriminate and do that. And that's what movie theaters are actually one of the places that do have price discrimination. All right. So we have price discrimination. Let's see what the profit will be. The high profit without it was $3,000. Let's see what the difference is. So the profit, right? You're going to get these cinephiles. You're going to charge them $20 a ticket. Maybe release the movie early, let them see it, but they have to pay a little bit higher price. But in addition to that, you also have where you charge every other time, you charge $12 a ticket. And there's 500 people that show up for that. And your costs are still going to be the same at $3,000. And so you generate $4,000 from the cinephiles, $6,000 from the casual fans, take away $3,000, $10,000 minus $3,000, you have a profit of $7,000. It's a good bit higher because you can price discriminate. That's why it's good to do that. Like it actually it's better for the overall surplus. Like, everybody's winning here. Like when you discriminate, like cinephiles, they get to see it earlier or something else to go along with it. And these casual fans, they don't care about that. They just want to go see it. It's whenever. And so everybody wins here. The cinephiles, the casual film, and the theater here, because it increases their profit. So everybody wins in this case with this type of price discrimination. Okay. Not all price discrimination is good or should be allowed, but in this case it's actually a good thing. All right, so that's it for the practice exam. Hope this was helpful.